Hi everyone, I'm Matt, this is Tom. Welcome to the session Here Be BigQuery at I/O. Just before I start, I've got a bit of a confession to make. I developed a bit of an addiction over the last 6 months. It started back in November, and someone internally sent me an email with an invitation to join the resistance. And for anyone who's played Ingress, you'll know what that means. I've gone through about 2 pairs of shoes. I've walked more miles in the last 6 months than I think I've walked in the last 6 years. It's been a really interesting experience because it's probably been one of the most engaging, social, fun sort of games I've played in years. And I've been working a lot over the last few months, few years in social gaming, particularly working with some big gaming customers in Europe, Gamesys being one of them. And it really got me thinking, how do you create that sort of level of engagement in a game? You know, you look at a game like Ingress, how do you get that level of addiction in a game? So when I started looking at this, you see these statistics that actually have been around for a couple of years, but so many games that developers are building, they get installed once, and then they're never played again. Something like 25%. And if you're writing a game, the finances associated with these, the real business of the game, is difficult. You know, an average game life cycle, it can range between weeks and months, but let's say 5 or 6 weeks. You know, when you're planning your business, that's when you're going to try and make the money. But if you can crack this engagement problem, you can start pushing out beyond that, and everything that comes after that is profit. And that's important when you're really in the business of casual gaming. So I started thinking about what are some of the drivers around this. And one of the big trends that I've seen come up, and this is some basic research I did out of Google Trends, was there's a big trend coming up around social gaming and the connected game. Well, of course, if you don't have a connected game, it's very difficult to actually make it social. You know, a game backend enables that social dimension to a game. Ingress is a good example, of course, in quite an extreme way. But there's some other drivers that came out as well for that. Second was, this surprised me actually, but a lot of people are starting to create connected games to push some of their game logic out of the client for piracy issues. So there's a great story you know, in the press a few weeks ago where someone had built a game simulation, a simulation game of a game company. And what they were able to do was detect whether the client had been pirated or not. And they played a bit of a joke and made sure that anyone who'd pirated the game, their company went bust, the virtual company went bust because of pirates. And there were all these forums online where people were, oh my God, this game's awful, I keep getting done by pirates. Yes. You know, it was great. And this is the sort of fun that people are starting to have. But I think probably one of the most important areas actually comes out of measurement. If you've got a connected game, you can start measuring in a way that really has not been possible before. And I think one of the reasons I'd really keen on doing this session is I think some of the work that Tom's done in Gamesys is some of the most advanced work I've seen in really developing this idea of a science of engagement, retention, and keeping those users playing the game. So I'm going to hand over at this point, Tom Newton, Director of Social Gaming, Gamesys.
Thanks, Matt. Hi, everyone. So as Matt just introduced me, my name's Tom Newton, and I'm a director at Gamesys, and I look after our social and mobile games business. So many of you probably have never heard of Gamesys. We were founded in 2001. We're based in London, in the UK. We have relatively quickly grown to be a market leader in what is arguably the most competitive online gaming market in the world. We currently have about $5 billion in turnover annually, and I think this says a little bit about the stature of the company today. We were the first company that Facebook approached to launch real money gaming on Facebook last year. And we've grown from about 10 people in 2011 to about 1,000 today. We started investing in social gaming, social and mobile really, in 2011. And we've grown that team organically from about 3 or 4 people to just over 100 today. We're currently operating 5 cross-platform games, so iOS, Android, and on Facebook. And we're even operating a game for PopCap and Electronic Arts, something we're very proud of. So today, really, we're just going to talk about a couple of the uses, particularly within the social team, how we use the Google Cloud Platform. I always have trouble saying that. So we're going to focus really on cloud storage, BigQuery, App Engine, and we're going to talk a little bit about the prediction API as well and how we plan to use that. So I get asked this a lot, particularly by developers. Why not build cool infrastructure? Why not have big data projects internally? And I sort of say we do, but we use Google because we like to focus on building products and trying to get away from building infrastructure. So really spending our time on trying to make really fantastic games and products for our customers. And so we can build with Google because we always plan for success, and success means that we're going to need to scale. And obviously, Google are an expert in building excellent scalable services. We really love all the Google APIs. Doing an integration with one of these Google services really means that through these rich APIs, you can really use them as just a building block and build a lot of interesting tools around them. And that's something that I think gives you a lot of synergies when you start to integrate your own systems with the Google Cloud Platform. And third, it's reliable. I think the less software that I need to run and to maintain and to monitor, the better. I just like to sleep at night. Call me lazy, but I enjoy sleep. And when we use Google Cloud Platform, we just, for the most part, don't need to worry about it. We can trust that it's going to do its job. So today, we're going to tell you a little bit about a new game that we have, and that's really just to paint a picture of what these connected products look like, these connected games, how they work. We're going to talk a lot about the importance of data, and then we're going to move on to talk a little bit about how we industrialize the learnings that we get from this data and build tools that help us operate our business. So Here Be Monsters is a pretty ambitious project. It started about 1.5 years ago. It's a social game, but we're trying to take it a little bit of a step further and turn it into a little bit more of give it a bit of an RPG feel. So it's an online kind of MMO. We're building it for the web, and we're also building it for Android tablets and the iPad. So it'll be launching on the iPad first, and that should come in about early September. We're really excited about it, so when it's out, definitely check it out. So in Here Be Monsters, you've got an entire world. It's an isometric 2D game. You've got an entire world that you can go and explore. And currently, I think, we're in beta right now. Currently, there's about 3,000 to 3,500 unique, distinct objects which exist within the game. And so I think the point I'm trying to make here is that Here Be Monsters is all about data, and we're just constantly pushing new items that the players can run around the world and collect. And once they do collect all these items, they can combine them in really interesting ways to craft bigger and better items. So a very, very typical kind of RPG mechanic. And why do they want to go around the world and collect all these items and build all these interesting things? Well, they do it because they want to catch monsters. And in order to catch monsters, there's a trapping element to the game. So you can build really, really interesting traps. You can travel around to the right parts of the world. You can put some bait in your trap, and then periodically you'll check your trap, and you're hoping that you've caught the monster that you're after. So now I'll just show you really quickly kind of what the game looks like. So hopefully you guys can see this. We had a little bit of a problem with the monitor earlier. Well, that looks good. Okay, so here's Here Be Monsters. That's my little character there running around. You can see a trap that I've set here, which is actually ready to check. But the point that I'm trying to make here is that the world is really big. This is just one isometric scene that players can visit and run around and interact with. And everything is interactive. You can see a couple of players down there, actually, sort of standing around. Some of them are probably fishing. I think we broke the game recently, so you can't see them, the fact that they're fishing. But all of the elements are interactive. So they can go around. They can pick up, for example, we can pick up some grass or a dandelion. We can go fishing. There we go. We picked up some grass, some dandelions. We put those in our backpack. And we can combine those. Again, we can take them back home, we can craft them into bigger and better items, and we can carry on with the game. And the way that we lead players through the game is really through the questing system. So players travel around the world and they meet non-player characters. And when they meet those non-player characters, they're given all sorts of different tasks that they need to do. So they start off very, very simple, and then they progress and get more and more complex, meaning that you really need to get out there into the world, find all these items, discover them, and discover the recipes on how you make better and better items. Just to give you a sense of some of the artwork in the world. So this is the world. It's a game that's based on the real world. And it's full of isometric scenes that you can visit. So if I zoom in, all of these little icons here, they all represent unique isometric 2D scenes that players can visit. And they're full of different kinds of items. So different trees, different butterflies, different flowers. I think the coolest thing about the game, too, is that the monsters are actually, they're all taken from real sort of human mythology. So if you wanted to find a specific kind of monster that you know about, chances are that it's going to be in the area that you would expect it to be in. But if you need to look it up, you can always go into the almanac. I'll just show you that as well. So the almanac, this is the dandelion pixie, which is one of the nicer-looking monsters that you can go out and try and catch. But there's a lot of information within the almanac that tells you all about all the different monsters. For example, a chimera, which is probably something some people are familiar with, the different baits that you might have to craft in order to trap them. So hopefully this is kind of making the point. There's a ton of data in this game. And the strategy behind this game is that we built a really interesting kind of CMS behind the scenes that allows us to push a lot of content on a weekly basis, because we expect that a lot of the most engaged users are going to tear through the content. So it's very, very important that if we want to keep them engaged, we need to be constantly releasing new and better content for this game. So I'll jump back in. Great. So, all right, so we've sort of painted a little bit of a picture. We've got a lot of players, they're running around, they're doing all these different activities. They can visit friends, they can send gifts, they can farm on their homesteads, they can craft items, they can collect items. So what does this mean? Well, what it means is that we generate a ton of events. There's a lot of raw data. And that raw data, I'd say 5 or 6 years ago, you probably wouldn't have recorded every single little step that a player made and all of the different properties that go along with that. But today, it's pretty much a necessity if you want to operate one of these games and you want to operate it well and optimize it and run it as a solid business. But that means you're going to generate a huge amount of data. And just to give you an idea of the sorts of levels of data that we see, and to be honest, there are plenty of other companies that are probably generating even more than this. Here Be Monsters right now has got about 10,000 people in a limited beta on Facebook. And those 10,000 players are generating about 1 million sessions a month and about 200 million unique events a month. So 200 million actions taken by 10,000 daily actives. We've got other games currently that are running. Game 2 there launched about 3 months ago. It's already got 150,000 people playing it every day. They're generating about 500 million events every single month. And then one of our larger games is generating in the billions of events every month. All of this data goes into BigQuery. And the reason why we really like BigQuery at Gamesys is that it's managed. So there's almost nothing you need to do to get set up. It scales. I'm going to say this a lot today. We really cannot integrate with a service that we don't, where we think that it can't scale. And BigQuery definitely has a lot of power and can do the sorts of things that we want to do with it. And then also the fact that you're just writing SQL. Anybody can write a BigQuery. And that's pretty awesome because our analysts, they don't like training days and this sort of thing. So because they already know SQL and they know it really well, the transition is extremely easy for them to go and start writing big, powerful queries. So to give you an idea of what happens within our platform, every day we've got all these players coming in, they're playing the game, doing all these different things, having a lot of fun. And at night, we aggregate all of that events data into a couple of aggregated tables just for convenience. And then we also upload all of the raw events into a table within BigQuery. So these aggregations, these aggregated tables, they really help to drive, they're there for convenience, but they help us drive really just high-level KPI reporting. And just to give you an idea of a couple of the tables that we use fairly consistently across all of our games, and you may want to define different ones depending on the style of game or application. I mean, I think this applies to really any digital product. The first is profiles. So profiles, when they're aggregated at night, you get a picture of what that user's state looked like at the end of the day, and that's fairly important. Sessions are fairly self-explanatory. They're essentially aggregated groups of events that match a user's play periods. And then we have transactions. So transactions obviously are really important. They drive the entire business. We want to know when did someone make a purchase, very, very specifically, so that we can go and really dig into what motivated them to make that purchase, what did they do once they bought that virtual currency or virtual good, how did they spend that within the game, what sort of activities did they engage with afterwards. It's really, really important that we dig in and understand the purchasing behavior and the behavior of our players, especially around the time of purchase. So hopefully I've been able to paint a little bit of a picture about what the game is, what kind of data it generates, the volumes of data that it generates, and that we effectively every night update a number of data sets and tables within BigQuery. So now that our data is in BigQuery, and you understand the structure of that data, we're going to talk just a little bit about how, this is probably one of the simplest things you can do, in fact, once your data is in BigQuery, and that is to integrate that data with spreadsheets. So to build, essentially, reports of various shapes and sizes using AppScript. This is incredibly easy to do. So using some of those aggregated tables, on our teams, we really we build up dashboards. So we build relatively complicated workbooks that everybody on the team has access to. We look at a lot of different metrics. We look at them, we slice them in different ways, but probably the simplest would be a simple daily dashboard. And these really just help to highlight sort of high-level KPI trends, and they often give you a bit of a hint that just sort of says, maybe we want to go and look at this. Retention looks like it's a little bit off for these players, or something's happened, and our active user base, the retention dropped over the next week, and we want to figure out why. And other people may want to look at things like conversion rates. So when we have brand new installs coming in on a given day or a given week, we really want to monitor the health of those users, compare them to other install days, other install weeks, so that we feel comfortable continuing with our acquisition spend. So now what I'll do is I'll just show you very quickly, for the developers that are in the room, of which I would imagine there are lots of you, I'll just show you how easy it is to basically integrate BigQuery with spreadsheets and to build reports this way. So what I've done here is I've just given you, within our games, we tend to have lots of different types of funnels. So funnels really are just sequential events, and the fact that we've got all this raw events data in BigQuery, it pretty much means we can define any funnel we want. And that's pretty significant and pretty powerful. So let's just take this as an example. This is just, I've called it the elementary quest funnel analysis. But let's say we've got a product manager. This week, they're going to focus on a very specific part of the game. They think they've seen a bit of drop-off. They've asked one of the analysts to go away and do a bit of ad hoc analysis. They've identified the issue. And now what they want to see is, as they make these iterations daily and they keep pushing these releases, we want to get that data in front of a product manager. And a product manager doesn't necessarily know how to go into BigQuery and write a bunch of SQL. Nor should they have to, because our analysts can simply create a new workbook that's specifically for that product manager, define a query that can go away and look at those tables, pull out all the interesting events that matter, and summarize that into a sample little dashboard. So how do you do that? Well, to be honest, I didn't even know this stuff existed about 9 months ago, and until I did a little bit of digging around and had a few chats with Matt. But we've started using it heavily, and it's fantastic. So you need to go into the script editor to start working with AppScript, and you'll find it under the Tools menu. So if you go to the Tools menu and you go down here, this script editor thing, if you've ever wondered what that is, well, for those of you that are new to AppScript, that will open the script editor. And what you'll see here is essentially JavaScript. So AppScript is basically JavaScript. And I'll just show you. So this function here is just a very, very simple function, which takes a query, which is just our SQL statement. I've put it in a comment down here just to make you to illustrate the complexity of the query. So this is a big, complex query. It's going to iterate over or query, I should say, about 200 million rows of data. And it's going to pull the results back, and it's going to put that into our spreadsheet. So how do you connect to BigQuery within AppScript? Well, it's actually really simple. So here's a little convenience function that I wrote, which is run query async. And it's really just broken down into 3 parts. So you've got this job description here, which is very, very simple to set up. And you can see that we're passing in our SQL statements. That's just a string that represents our SQL statement. You can then insert the job. So again, very, very simple. That's basically passing it off to BigQuery and asking it to actually execute the query. And then all we do here is we just wait. We wait asynchronously, and we poll to see if the job is complete. And then finally, when the results come back, we go ahead and fetch them, which is here, and we return them. And that's essentially it. So if we run that now, hopefully this will... Oh, sorry, this is one other thing you can do, which is, again, for convenience, is you can very easily just add your own custom menu. So you can see this little bit of code here. That's all that does. So I get a nice little menu item here, and this button here is hooked to my function. The other thing I'll mention as well, when you're building up, say, daily dashboards or monthly dashboards, a really nice, simple way to get them to automatically run every day is with the triggers functionality. So this little icon here is the triggers. So to set up a new periodic trigger is extremely, extremely simple. Just go here and add a trigger. Select the function that you want to run. Select that you want it to be time-driven. And there's a bunch of different options here. So if this was a daily thing that we wanted to refresh, we'd select daily, select the time we want it to run. So let's say we want to run it at 6 a.m. We'd save that. And now this spreadsheet is going to automatically run that query for you at between 6 and 7 a.m. And so when you get it in the morning, you just pop open your workbook, you open your phone, and that funnel analysis is right there for you to look at. So let's just run the query very quickly. Again, so this isn't a massive, massive data set, but it's pretty big. And obviously, we're running this for our other games as well on much larger data sets. This is I think it's about 200 million rows. So it's running, and there we go. So all of our interesting data that we were interested in about these different events throughout our funnel, we've tracked that. We split it by tier 1 countries and non-tier 1, which is basically English-speaking and not English-speaking. And we can see the results visualized in our graph below. So that's how easy it is, really, to take these massive data sets and actually produce a workbook, a spreadsheet that everybody knows how to access, and really get this important data in front of the teams that are working on the games every day. Great, so we're going to switch gears a little bit now. Again, that was a relatively simple example of what you can do to hook BigQuery up to spreadsheets using AppScript. There's a lot of other things you can do with AppScript as well, so definitely have a look at it. You can convert those spreadsheets to PDFs. You can email them to everybody. There's loads and loads you can do with them, so definitely have a good look at that. So now we're going to talk a little bit about how we build tools that kind of industrialize the learning. So we do a ton of ad hoc analysis. We've got 4 or 5 analysts on our team that are looking at our data every single day. And all right, that's what we've looked at. But the next thing we're going to look at is how we take those learnings and how we build tools that also interact with our data to kind of automate optimizations that we see or automate tooling that can help us. And so the first one we're going to talk about is a tool that it's called Mailman. It's an engagement tool, and it's built with App Engine. So App Engine, we get asked this a lot as well. Why do we use App Engine? If anybody wants to go for a beer later, I could talk to you for about 2 hours on all the reasons why I love App Engine. App Engine is fantastic. And integrating with other Google services really make it even better. But just simply, if we had to kind of boil it down into a couple of points, it's super productive, right? So I think I've said this already today, but we just like to focus on the problems and leave some of the heavy lifting to the Google Cloud Platform. And it's pretty powerful, particularly for small teams that are trying to grow their businesses. You need every minute of every day on your products, not on infrastructure. The deployment model is really cool. All of our guys love the deployment model. We can't actually take advantage of it as much as, say, if you had a website that you could, but we still make very, very good use of it. And then, of course, scale. We've mentioned this once or twice. We're going to mention it again. We cannot integrate with any service that we don't believe can scale along with us because we're always planning for success. We're expecting big numbers, big traffic, big concurrency. And if we're going to build tools that run alongside our games that our games platform is going to be speaking to at that sort of level, we have to make the right decisions, and we feel very, very good about our choice of App Engine. We've been working with it for about 2 years now. So Mailman, just to dig into, this is just one of the tools we built. We built a number. We decided to focus on these two today. So Mailman really is an automated delivery mechanism or delivery tool for messaging. It's really important within our games. People aren't playing our games all day, and that's healthy. Some of them actually do, which we're worried about, but most of them don't, right? Most of them are normal people, and they come and go, and they play a lot of different games. And so when we do our ad hoc analysis and we see the sorts of drop-off points that maybe are concerning to us, or we see where people get stuck within the game, sometimes it's too late for us. And because they got stuck in the game at a certain point that we've now identified, they're not planning on coming back. And so this is when we have to basically reach out to them. And this is just one case, right? We reach out to our players all the time through email, through push notifications and Facebook notifications. So the logical sort of components of Mailman are lists. Lists really answer the who. So the powerful bit about lists is that lists are basically groups of message recipients, so they represent players. And the list can be defined with a query. So anything we can write a query for, anything that we turn up in our ad hoc analysis, we can just define a new list with a query. We use a little bit of templating to make sure that we can use those same queries over and over sort of daily if they need to be refreshed daily, but it's a pretty powerful thing. And what actually happens technically under the hood when one of those lists are created is that under the hood, we basically make a query to BigQuery. And for those of you that are familiar with App Engine, we store the results, no matter how large they are. We store those results in the blob store. And so jobs, the jobs when they actually run, the messaging jobs, this is really where we take advantage of App Engine's scale and parallelism, because we make use of the MapReduce API and the pipeline APIs. And that means that essentially we can spin up a lot of instances to go away and map over the results that we got back from our query. And so jobs really represent, if lists are the who, then jobs really answer the sort of the what, the when, and the where. Because what happens when this MapReduce job runs across all of these instances that just sort of fire up magically is that for every single recipient and message that we're going to send, we enqueue a task. And so this could, sometimes we run huge volumes of messaging, whether it's email, push notifications, Facebook notifications. You can very easily run a job one night that's going to be to millions of users. And App Engine can handle that pretty seamlessly. And one of the things you'll find when you start working with App Engine is that there's so many great APIs and services that are made available to you when you build on that platform. And so one of the ways in which there's a feature called ETA, and ETA essentially means that you can specify the earliest time that you want a specific task to run. And so we actually use the ETA feature within the task queues to make sure that part of our query on that list, one of the columns of data that comes back for every row is actually, it's a hint. And it hints to us what time of day we should actually send out a message to make sure that we get the highest chance that the user's gonna respond to that and engage with that message and come back to the game. And so we use that a lot. And obviously, we deliver across the different channels. So that's Mailman. The next one we're going to talk to, this is the last one, is called Cobra. And Cobra is also built on App Engine. So Cobra is really interesting because, as you can imagine, once your game's mature, you launch a game, it's out there for 3 or 6 months, you're doing loads of optimizations, you really start to push it, it's getting bigger and bigger and bigger. And slowly what you see happening is that you can't just address users that are, say, right on the bleeding edge. And you can't really just address users that are on day 1 or day 2 or day 3. But there's lots of different strategies that you want to kind of deploy to make sure that you have the best chance at monetizing users at all of the different sort of stages of their life cycle. And so that's what Cobra does for us. Cobra is basically a pricing and promotions engine, which is aware of players' profiles. Cobra is loosely integrated with BigQuery, but is also heavily integrated with our games platform. And the other thing that it does is it acts as a middleman through all of the transactions. So no matter what the platform, all of our transactions securely flow through Mailman, are authenticated and validated, and then they proceed. So if we think about the pricing and promotions engine, what's actually happening today is a very iterative process where we go away and we do a lot of ad hoc analysis. And from that ad hoc analysis, we come up with strategies. So different pricing and promotion strategies that we want to basically program into Cobra and then deploy. And when someone actually does interact with one of these offers or a promotion or responds to maybe a subtle change in some of the pricing, we record that. So they make a purchase, it's tagged with a bunch of information about the configuration that they responded to, and that flows down into our games platform, which again, nightly comes back up into BigQuery. And so we do a lot of manual iterative processes there. So, and that works really, really well. But one of the next things that we're looking at is how we can use something called the prediction API. And this is another service from Google, which I'm told is really, really heavily used internally and not used that much externally. But we definitely have a use case for it. So just at a super high level, so we're running out of time, the prediction API kind of has two functions. If you have a model, so you've got a lot of raw data, which obviously we do, and many of you, I would imagine, have as well, and you think that if you did some analysis on that data, you might be able to come up with some statistically significant indicators of an outcome. So for us within Cobra, that might be, this user's profile looks like this right now. Which type of offer do I think they're most likely to convert with, or to convert on? So basically, you just put a bunch of data in cloud storage. You point that at the training endpoint. Prediction will suck up all that data, will train the model for you, and when it's complete, you can actually query that model. So you can query that statistical model with essentially what would be a row of data, so a row of these features, and that would try and predict what that example value might be. So Cobra with prediction, you can kind of see how that would work in. So the way in which we might use it, or one of the ways in which we might use it, is to just help us, help basically train on our financial data, train on our profiles data, and try and help us make even better decisions about what kind of offers to surface to players based on where they are in their lifetime. And that's a pretty powerful thing. So that's something we're experimenting with, and hopefully maybe next year we can come back and talk about how that went. So just to sort of recap, my big thing is, we've grown this social team at Gamesys from about 4 people sitting in a little hallway to 100 people that occupy most of a floor. And I think one of the ways in which we've done that is that we try and stand on the shoulders of giants and not try and replicate a lot of work that can be done by others. And these are fantastic products. And if you kind of invest the time in understanding how they work and what they can do for you, you'll spend less time on all the boring, painful stuff, and you'll really be able to get at your data, build really cool tools, and focus on your game, which I think is paramount.
Great, thanks, Tom. I hope you got a sense of some of the insight that data is really bringing to gaming. I can see that I'm going to lose another 6 months of my life when this game launches. But I think there's some trends that I'm seeing across the industry. And one of the things I'd say is, every successful game company seems to have 3 components. The first is obviously the technology, and that's often the obvious one where people start, hey, what technology, which platforms do we choose? But it's what you do on top of it. There's obviously the marketing department and the user acquisition side, critically important. But the thing I think that is somewhat neglected, where there's a real opportunity, is in this area of analytics. And one thing I'd say about the Google platforms, not just the cloud platform that I'm involved in, but actually all of Google's services are helping game developers and players across the whole suite. The cloud platform particularly, I think Tom really brought out, what's important. The platform is something really which we built for us here at Google. This is our success. And our strategy over the last 18 months is to externalize that so that people can use it. So for me personally, it's really exciting to see the work people like Tom and actually many of you in the audience are really starting to do to build in a different way and into the future, not just of gaming, but technology as a whole. So I know we've had a little bit of time. I can see we've got about 4 minutes on the clock for Q&A. So we'll take some questions now, but if you've got anything else, we'll be at the cloud booth later on. So any questions now? We'll take a few. Otherwise, we can grab some beers. Yeah, question here.
Did you start with BigQuery, or did you have to migrate over from another RDBMS? And if so, what challenges did you see?
For this sort of work, to try and work with data sets that are this big within some of the other relational database services that are out there, we really struggled. We really struggled, and we also spent a lot of time just trying to make sure that we ran into so many different problems along the way. Particularly as when we started some of these games, we never thought we'd generate this much data, and at the time we didn't really have a good understanding of the fact that recording all this data at this fine-grained level was really necessary. And so when we started looking at BigQuery, we were using MySQL databases, and that worked relatively well to a certain point. But it required a fair amount of maintenance and human intervention and sysadmins and experts with that technology. And we just want to make games. We don't want to have a bunch of guys on the team that are constantly focused on trying to maintain these pieces of software. Not when there are services like this that are out there that you can leverage that just make life that much easier. And to be fair, are way more powerful and come with fantastic APIs. So I hope that answers your question. We can talk to you a little bit more about it afterwards.
I have one more for you if I can.
Sure.
Yes, so you have these ETL processes that you're running like, I don't know, at the end of the day or something, right? And then basically you're using, all this infrastructure as a sort of like all-up cube, and you have all these services that you run out of it.
Sure.
So I'm curious as to, what were the technical reasons that for the new games that you're making, that you didn't choose just to build the whole thing on the Google Cloud Platform and avoid having your own servers right now. So whether there were some latency things or some technological things that were missing, or because then it would avoid having to do the ETL extract at the end and then run your own app engine processes and then extract it again out and putting it back in.
Sure. So sorry, the question is why don't we build the games themselves on App Engine or on Google Cloud Platform?
What are the technical features that are missing from there? Yeah.
Well, for App Engine, for games that require bidirectional socket communication, you're not going to be able to do that on App Engine at scale at the moment, not particularly well. But now with Compute Engine coming along, there's absolutely no reason why you couldn't build an entire game stack on the Google Cloud Platform. I think the thing to remember is that we started building social games about 4.5 years ago and built up a platform on another provider. And we've got a lot of code there. We can leverage that. We can build games really, really quickly on that platform. But it's not to say that, to be honest, I'm dying to find a game that sort of fits. Maybe one of our next ones that we can actually build with App Engine if it makes sense, if it doesn't require bidirectional sockets.
So two questions. What are you guys using to visualize the data? Is it all just spreadsheets with queries and put it into a chart? Or are you using any other tools to visualize it?
Some of our analysts we kind of let people kind of pick and choose what tools they want to use. So we have been fairly heavy users of Tableau in the past. Some of our analysts just like to work within Microsoft Excel sometimes, and they use the connector for Excel. and they do a lot of visualizations in there. But for the most part, to be honest, our core dashboards and some of our most, I'd say, insightful information sits within these dashboards that we put together for each product now. And a lot of the more ad hoc analysis is actually done by the analysts, so they can kind of choose how they want to visualize it and then circulate it to the teams.
Hi, I was actually wondering if you can speak a little bit about the predictive models that you were showing there. Sure. It wasn't clear, at least to me, if that was something that was done within the app engine, or is that something that you were doing out external, and what kind of tools are you using for that?
Sure. I would kind of rush through that. I apologize.
No worries.
The prediction API is actually another API provided by Google, okay. And we can talk a little bit. Do we have to get off stage?
I'm thinking that.
Sorry, someone's giving me a bit of a wave. Yeah. I'll come and have a chat with you about that in a minute.
Okay, sounds good.
Okay, I think, are we okay to have a chat at the booth maybe later? Sure. I'm just thinking that we're probably timed out here. But thanks, Tom. Thanks, everyone, for coming. And if you have any questions, please come by the booth.